linear approximation, tangent line approximation, and linearization. We have a curve f of x and a tangent line, which is the straight line you see right here. So we have a tangent line, a straight line, we have a curve f of x, and then when x is equals to a at this point, the curve and the line have the same slope, which is called f prime of a. So f prime of a is equal to a number that represents the slope of the curve at x equals to a. And this slope is also the slope of this tangent line. So let's cut a piece. So I'm trying to cut a piece in this area. So let's cut a piece in the neighborhood of A and then zoom in. So we cut a piece and then we bring this piece over here and then we zoom in. So we have a big picture like this. Do you see that the curve looks like a straight line? I should say the curve looks like the tangent line in this neighborhood. So this curve looks like the tangent line in this neighborhood. Do you see that? The purpose of this study of linear approximation, another name is called tangent line approximation, is to use the tangent line to approximate the curve when x is near a. I should say this one more time. The purpose of this study, which is linear approximation, some textbook call this tangent line approximation, is to use the tangent line, the yellow line you see right here, to approximate the curve, which is the purple curve or the pink curve, when x is near a. So let's do some construction. We need to build a formula to describe this approximation. You are trying to use a line to approximate the curve. Then you have to give me a function for this approximation. Give me one function to describe the entire approximation. So the first step is step 1, starting from the point where x is equals to a. So we're starting from this big yellow point, and then we have to take one more point, and then we have to write out the rise over run. So how do we get another point? So to get another point, I will just do a rise over run like this. So I will just go this way and then go that way. And then do we agree that we have a point right over here? We have a point right over here, right? And then this point, I will just call this x. All right, so I will just call that x. Now, here is something that you have to pay attention to if you do not want to read your textbook. The second point, so the second point, the blue point, is close to the curve. Do we agree that the second point, the blue point right over here, is close to the curve? So this, I call this a y2. So we have a y1, the yellow point, y2, the blue point, we call this y2. So y2 will be taking the measurement of f of x from the curve instead of the line. So instead of taking the measurement at this point, I will just take a point right over here. Since they are so close, I will just take this because we are trying to approximate, right? So I'm going to take that instead of the point on the straight line. You will see why when we deal with a real example. So what is this point called? This point, I will just call this f of x. So I will just call this f of x. Maybe I should adjust my pen a little bit so I won't occupy too much space. And then we have to do a rise over run. So what is the slope of this straight line? The slope of this straight line. Oh, by the way, this f of x, I'm going to put a circle on it. So I will just call this approximate. You will see why when we do a real example. And then what is rise over run? So the slope, what is slope equal to? Slope of a straight line. So slope is equals to rise over run. So rise is y2 minus y1. And then run is x2 minus x1. So using the points, the coordinates we have, that means slope is equals to y2. So that will be f of x minus y1, right? So y1 is f of a, and then x2 is, I will just use x, so any x value over there, and then x1 is equals to a. And then what is slope equals to? The slope, what is the slope of the curve and the straight line at the yellow point? That is f prime of a, right? So that is f prime of a is equals to f of x minus f of a divided by x minus a. Okay, And then this f of x, it looks like the f of x is the blue point on the straight line, but we are going to take an approximate value. So that value, we just take that straight from the curve. So the y2 is actually a point on the curve because we are trying to do approximation. So keep in mind. And then the next step, can you multiply x minus a on both sides? So you have x minus a times f prime of a equals to f of x minus f of a. Once again, the f of x is the approximation. And then you add f of a to the left side. So we have f of a and then plus x minus a times f prime of a equals to f of x. So the f of x is what? Is the curve, right? So the f of x is equals to a curve. So now let's write a conclusion. So for the conclusion, I am going to move the word over here. So I am going to write f of x. So since f of x is on the curve, not on the straight line, right? Can you see this one more time? May I have your attention over here in this spot? Is an approximation, not exactly on the straight line. I am going to say that f of x is approximately equals to, so approximation, approximately equals to, we have f of a plus f prime of a and then times x minus a. So this is just equals to what? This is just equals to the y-intercept plus the slope times x. Once again, we have something like y equals to the y-intercept plus the slope times x. So what is that called? That is called a points. That is called a slope-intercept form. And then what is this called? This has a name. This conclusion. This is called linear approximation. So linear approximation. And some textbook call this tangent line approximation. So also write this down, tangent line approximation. Of the curve f at a. F at a. And then what about linearization? So for linearization, we are trying to change the f of x to L of x. So let's switch to a different colors. So if you switch f of x to L of x, so you have L of x equals to f of a. We copy everything else one more time, plus f prime of a times x minus a, and then this is called linearization of the function f at a. So this is called linearization of the function f at x equals to a. So now we have a formula. Okay, so now we have a formula. The best way to understand this formula is we carry this to an example. So let's do that right over here. So don't worry about the formula. When I use the formula, I will mention the formula one more time. So we have a linear approximation and linearization. So since that is an approximation, so that's why we use the symbol for approximation. All right, so let's move on to this example. What I am trying to do is I'm trying to find the tangent line approximation and linearization of the square root function at a equals to 4. So first of all, we will need the what? We will need the slope immediately. So let's find the slope. So the slope f prime of x, that is equals to 1/2 and then x to the negative 1/2, which is 1 divided by 2 times square root of x. That is the slope of the square root function at, I should not say any x value, when x is greater than or equal to 0. So take a look at the curve, the red curve, that is square root of x. So pick any x value. So I should say we have a curve, square root of x. So pick any point on the curve. I should say use one equation to describe the slope of this curve when x is greater than or equal to 0. That equation is right over here. 1 divided by 2 times square root of x describes the slope of the curve when x is greater than or equal to 0. And then at that point, we have f prime of 4. So f prime of 4 is 1 divided by 2 times square root of 4. This is 2 times 2, so which is 1/4. Then we have a slope. All right, so other than the slope, we also need a point. So f of 4 equals to the square root of 4, which is equals to 2. And then we have a point when x is equals to 4, y is equals to 2. You study how to build a tangent line, so you can easily use this to build a tangent line. And then the tangent line is in blue, as you can see in the picture, right? Okay, now let's do the tangent line approximation, or some textbook call this linear approximation. Now we are trying to answer the question. So let's answer the first thing, tangent line approximation. So tangent line, some textbook call this linear approximation, right? Let's draw a parenthesis, linear approximation. First problem, I always recall the formula, that is f of x approximately equals to f of a plus f prime of a times x minus a. Now, how do we use this? The formula is saying that what is f of x? F of x, I will just still call this f of x. Let's do the plug-in on the right-hand side. So f of a, when x is equals to 4, y is equals to 2. And then plus the slope is 1 over 4, and then times x minus 4. And then what about the left hand side? What is f of x? F of x is given right at the beginning, that is the square root of x. So now the tangent line approximation, the linear approximation, is saying that the given function can be described by, this one is 2 plus that, so we have a 2 plus 1 over 4 times x minus 1, so we have a 1 plus 1 over 4x, right? So they are saying that the square root, the curve, can be approximated by 1 plus 1 over 4x, which is the tangent line. The curve can be approximated by the tangent line when x is near 4. So this is your curve, and then this is your tangent line. The curve can be approximated by tangent line. So let's say this. So that means when x is near 4, like in this neighborhood, when x is near 4, do you see that the curve just look like the tangent line? Looks like the tangent line, not really the same as the tangent line. So when x is near 4, the square root can be approximated by 1 plus 1 over 4x, which is the tangent line. So that's why when I said that, if you go back to the beginning of the video, I said that this f of x is an approximation, because we have to compare the tangent line to the curve. All right, so back to this business, what else do we have to do? We have to do a linearization, right? Okay, so let's do a linearization. So let me change to another color. So for the linearization, I will recall the formula. Linearization, so we have L of x equals to f of a plus f prime of a, and then times x minus a. So the L of x, that is equals to 2 plus 1 over 4 x minus 4, and then you clean that up. The linearization is 1 plus 1 over 4x. Okay, so what happened is we have a curve. Okay, so we have a curve. I will just draw it like that. And then we have a tangent line. So we have a curve, and then we have a tangent line. Okay, so we have a curve, we have a tangent line. And then we are saying that when x is equals to 4, the curve looks like the tangent line, and we are using the tangent line to approximate the curve in this neighborhood, right? We are trying to approximate, trying to estimate, approximate, we are trying to guess, right? But how good is this approximation? We just came up with our conclusion, that is a 1 plus 1 over 4x, and then the approximation is right over here. We came up with this conclusion, but how good is this? How do we find out? So to find out, we have to use it. So to use it, we have to try to use the approximation. So we have to try to approximate. How about some value around 4, like a equals to 3.96, so that is in the neighborhood, right? So a equals to 4.03. So all you have to do is you record this first, so approximately equals to 1 plus 1 over 4x, and then you just do the plug-in. So you have a square root of 3.96 approximately equals to 1 plus 1 over 4, 3.96. So do the math. This I will use more digits, so 98997. The other side is 1.99. Is this a good approximation? I totally agree. This is a good approximation. How about 4.03? So you have 4.03 approximately equals to the tangent line 1 plus 1 over 4, 4.03. So this one we have 2.00749, and then the other side we have 2.0075. I will still call this a good approximation. So now let's do something crazy. How about a equals to 9? That is so far away from 4. Is this still good? So one side we have the square root of 9, the other side we have a tangent line, and then what is that equal to? So this side gives me a 3, this side is 1.44. This is a bad approximation. Why? Why is this bad? Because the line, the tangent line, is far off the curve. Don't worry about rewinding the video. I will just copy this picture. So I will just copy this picture and then paste that over here. And we can even make it bigger. So in this neighborhood, the curve and the line, they are so close, right? But when x is equals to 9, we have a point right here and a point right over here. They are not close. That's why the approximation is bad. Alright, so that's it for this video. If you like it, give me a like, share, and subscribe, and I will catch you all in the next one. Signing out.